Hello, this is Domenico with another production possibilities curve paper 3 type practice question. This will all be part of my playlist for the first unit, introducing the circular flow and the production possibilities curve. There are two additional paper 3 type practice questions related to the PPC with regard to constant versus increasing opportunity costs. And this is an additional one. This will all be linked in the video notes below. So let's take a look at this question. So here we go. Here we have, it says figure 3 illustrates the production possibilities for wheat and rocket production in China. Resources in China are assumed to be fully employed, full employment of resources, land, labor, and capital. Here's figure 3. On the y-axis, we're measuring the quantity of wheat in millions of tons. And on the x-axis, we're measuring the quantity of rockets going up by units of 2. So let's look at the first question here. It says, question A, assuming an initial production of 70 million tons of wheat, calculate the opportunity cost for China if the production of rockets is to be increased by 100%. So I'm going to ask you to pause this video and look at this graph and look at this question and attempt this question on your own before we break it down and answer it. So please pause the video now. Okay, so what did you come up with? What answer did you come up with regard to the opportunity cost as rocket production is increased 100%? So let's look at the initial production point. So we have 70 million tons of wheat. So here's 70 million, and that's at this point over here. So I'm going to mark that point. Maybe on the test I'll mark it as point A, just so I can see where my starting point is, and perhaps I can also highlight the level of production of both sets of goods or both combinations of goods. So we have 70 million tons of wheat, and we're producing 4 rockets in this case. Then it says we're going to increase the production of rockets, not wheat, rockets. Students may assume it's an increase in the production of wheat and then calculate from there, but here it's saying we're going to increase outputs of rocket by 100%. So 100% of 4, so 4 times 2 is going to take us to 8. So 100% of 4 is 4. We're going to add another 4 here. So we're going to increase production from 4 to 8 units. All right, we're adding an additional 4 rockets, so that's going to double the amount from 4 to 8. So production will now go to this point. 8 rockets, and then how much wheat are we producing? Here we are. We're producing 30 metric tons of wheat. So I'm going to mark that point B, and I got to figure out, to get an additional 4 units, what was lost here. So that's what we're going to be calculating for this question. That's the opportunity cost. We've lost the opportunity to generate this amount of wheat production. So simply 70 million tons of wheat minus 30 million tons equals 40 million. So we've lost production of 40 million. So it equals 40 million tons. That's the opportunity cost. 40 million tons of wheat have been sacrificed to increase rocket production by 100%. All right, that's going to take us from 4 rocket units, 4 rockets, excuse my spelling, to 8 rockets. Okay, so the opportunity cost is the 40 million tons. So the value here is we've dropped production by 40 million tons. These are notes to myself, so I understand what's going on. to increase rocket production by another, in this case, 4 units of rockets. Okay, we can also simplify that, so it's 40 million tons 40 million tons to generate, here's a ratio here, to generate 4 additional rockets. Which can break down to 10 million tons sacrificed to produce each additional rocket. All right, so to go from 4 to 5, we've sacrificed 10 million tons, and then from 5 to 6, 10 million tons, and then from 6 to 7, another 10 million tons, and then from 7 to 8, another 10 million tons. So in total, we get 40 million tons lost, opportunity cost, to generate 4 rockets, or for each 1 rocket we produce, each additional rocket, we've lost 10 million tons. Negative 40 to gain an additional 4. So we've answered that question. Okay, great. B, that's the A question. Let's move on to the B question. This is a very common question that I see the IB asking. State 2 factors. They can ask this at the micro level, the macro level. They're looking at what causes shifts in production, increases in the long run aggregate supply curve or Keynesian aggregate supply curve in macroeconomics, or the production possibilities curve. What are the factors that can cause the production possibility curve to shift, in this case, outward? And the first thing you should think of is the following 3. We're going to list 3, even though we only need 2. Number 1, any change in the quantity of resources, factors of production, land, labor, capital, entrepreneurship. So in this case, in order for the curve to shift outward, we would need an increase in the quantity of resources. If we acquire more labor, land, capital, we can generate more outputs because we have more inputs to work with. Number 2, any change in the quality of resources. So if the quality of the resources improve, you go from mid-skilled labor to mid-skilled labor to high-skilled labor, or you're going from low-skilled, transitioning to mid-skilled labor to high-skilled labor as you educate your population, then the production possibility curve will increase. And the third factor is a change in technology. If the nation acquires innovative, new, productively efficient technologies, then with the same quantity and quality of resources, you can produce more because you have productively efficient technology to do it. All right, so you just need 2, but these 3 should just pop up in your mind immediately. In microeconomics, macro, think change in quantity of resources, quality of resources, change in technology, and that would be a suitable answer. And that's it. If you have any questions, feel free to comment those questions below, and don't forget to subscribe and to like. Thank you so much.